Okay, so problem 3.13, it tells us that in the voltage divider circuit, the no load value of V naught is 4 volts, assuming that this resistance isn't connected. Or 4 volts, yeah, V naught would be 4 volts, but when this load resistance is connected, V naught drops to 3 volts. So it tells us to find the load resistance when it is connected. So these are two separate problems. So I'm going to go ahead and make this part 1 because you want to find R2. Right? So we have a simple circuit like this. We call this A, B, and you know that V naught is 4 volts. This is 20 volts. Right? So we will label this bottom node as ground. And I'm going to use a nodal analysis for this. So this is 20 volts. Here it's 4 volts, right? Because this is 0. So the potential difference is kind of implied here, 4 volts, 20 volts. And we know the resistance, the first resistor. So all we're left is R2. So I'm going to go ahead and write this down. So KCL doesn't change. There's only one current going through, so there's no reason why we should write a KCL in the first place. So we're going to write EFC. So we have two equations for components, for the 40 ohm resistor and then the unknown resistor. So I'm going to call this, drawing red, IS. So then IS is equal to 20 minus 4 over 40. So we know, so 16 over 40 is, I don't know off the top of my head, it's 0.4 amps. So then we also know that IS, or 0.4 amps, is equal to 4 minus R2, or minus 0 over R2. Yeah, so 0.4 R2, we can just switch these. So 4 over 0.4 is 10. So we know R2 is 10 ohms. Right? So here goes. Now we know our first component. So now goes part 2. Part 2 is now, looks like this. And now our unknown is RL, right? The label is circuit, label ground. We know that V naught across is 3, or sorry, there we go, is 3 volts. And now our unknown is RL. So let me go ahead and put some more space here. There we go. Sure I'm recording. Yeah. Okay, so shoot. There. Now we have a KCL, right? Yeah, label it, make it blue so we know IS I1, I'm gonna call this I2. So KCL IS equals I1 plus I2. Now we have 3 EFCs. We already know the equation for IS, but I'm gonna rewrite it again. Well, the 3, instead of 4, it's 3, there's a voltage drop. But I1 is equal to 3 minus 0. Oh, no. There. Minus 0 over 10. And then I2 is 3 minus 0 over R2. I'm just gonna, this is kind of simple. I can do it by hand, but I'm just gonna use my calculator. So 4 equations, this equals I1 plus I2, IS 17 over 40, I1 equals 3 over 10, I2 equals 3 over R2, and X and R2. All right, so since we know, assuming this is correct, we can just ignore R2. We know what I2 is. Let me just say this. So we know I2 is 1 over 8. Right? Then we can say R2 is equal to 3 times 8 over 1, which is 24 ohms.